Hello, 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 ladies and gentlemen, and welcome back. Welcome back. We're looking at question number 9 on the 2013 Manitoba Math Contest. Circles of radius 1 and 2 are externally tangent. Isosceles triangle ABC is inscribed around them as shown. Side AC is tangent to the small circle at D and the large circle at E. Prove that AD equals DE equals EC. Okay. Well, it's isosceles, so if I drop a perpendicular from A, it should, must remember, always draw my circles first, then my triangles. But a perpendicular from A should go right through the centers of our triangles here, or centers of our circles. That's not so bad. I mean, it kind of looks bad. Alright, that's a little better. Anyway, A, D, E, we want C. We don't really, I think, need this half. I'm going to call the centers of the circles P and Q. So we start off by saying let P and Q be the centers. And AE an altitude of the triangle. Because AE is going to go right through these centers. We could even say that, although a picture I think is fine. PQ are on AE by symmetry. Okay, so there we've used the fact that it's isosceles. Now, what about these tangent points? Well, something we always do with tangent points is we connect them up to the centers. That's why I named P and Q in the first place. And now we know these radii. So this is 1, and this is 2. I guess we've got right angles down here as well. Okay. So, we want to show AD equal DE equal EC. So, we have, so noticing the 1 and the 2 here, we have a similar triangle right here. Because we've got this common angle. So I might say something like, notice ADP is similar to AEQ. And that tells me that 2 is equal to QE over PD, because that's 2 over 1, and that's literally the ratio of the radii. But it also means that that's EA over DA. Okay, but EA is 2DA, but ED is EA minus DA, which is just 2DA minus DA. So ED is DA, and that's the first thing that they wanted us to show. So that falls out fairly quickly. Now, can we use similar triangles to do the other one? Okay, what to do here? So unfortunately we don't have another sort of circle here, making a right angle there, and it would have to have a radius of 3, but I can't guarantee that. I do still have another similar triangle with things swapped around, because we got this right angle down here. So does that lead anywhere? So notice that, I don't know, let's say ADP is similar to, and you got to make sure the one with the right angle matches up. So now we want AEC. So that tells me that so AD over AE is the same as PD d over EC is the same as AP over CA. Now, none of these have EC in them. Well, no, sorry. Wait, how do I have EC here? Oh, silly me. This should be an F. We already had an E in the question. Ah, well, that's embarrassing. Fortunately, it doesn't change much of what we already had. So AD and AF. And then this is FC. Okay, now PD is 1. FC, so EC and FC are the same because they're both tangents. So EC equals FC, since they are tangents from the same point. C. Okay. So that's useful. We could also say, here's a 2, this is a 2, a 1, and a 1, but I'm not entirely sure how that's going to help us. But that does mean that we've got... So we do want to relate it all to AD. AD over AF is 1 over FC, which is really EC. And that's one of the ones that we want to talk about. So if only I had more information about AF. Well, AF is 2 more than AQ. Not entirely sure. The EC thing is really causing me a problem. I guess I could say EC is AF over AD, but again, that's not really helping me. AF obviously has to be AD squared, right? But not seeing why what's going on there. So I suppose AC, we could focus on AC. AC is just, so AP, by the way, let's change it up like this. So AC is just AE plus EC. That's nice and true. What can we do here? Genuinely don't know. Alright, I'm going to call this length X, and now we know that this is X, and I'm going to call that R, and I'm going to let that be Y. So 1 plus Y squared is equal to 1 plus X squared, and then 4 plus Y all squared is 4 plus 4x squared. So 4 plus y squared is just 4 times 1 plus y squared. Doesn't that mean y has to be 0? Oh, no. It would... we can expand it out. So I'm choosing to do a computation route because I don't think I can do a similar triangle thing anymore. I'm sure there is one, one's not coming to mind right now. So that's 16 plus 8y plus y squared is 4 plus 8y plus 4y squared. Those cancel, so we'll have 12 is 3y squared. Y squared is 4, so y is 2. And that tells me x is root 8. So all I need to do is show that this down here is also root 8. Alright, well, we know that it's y plus 6. Y plus 6 squared plus EC squared is equal to EC plus 2x squared. But then that's 8 squared plus EC squared is EC squared plus 2x is root 8, so 2 root 8 EC plus 4x squared, but x again is root 8, so this is just 4 times 8. So 64, cancel out the ECs, 32, so 64 minus 32 is 2 root 8 EC, but then that's 32 2 root 8 EC. So that's 16 is root 8 EC. That's weird. Oh, this should be a 4. This should be a 4. Because it's 2 times 2x EC, so it should be 4. 4, 4. That puts this down to 8. Therefore, EC is root 8, which is x. So I broke down and did it computationally. I think there's probably some similar triangle in there. I really think there is. I just can't think of one right now. And introducing these x's and y's certainly made the question quite quick. Just, I would say, less elegant, but someone who really likes algebra would say this is more elegant than silly old geometry. But that finishes off question number 9. We got one more question to go, so I will see you for question number 10 in the next video as we finish off the 2013 MMC.